Welcome to VEDHA online classes. VEDHA online classes is providing the live online tuitions for intermediate CBSE, EAMCET, IIT-JEE, BITSAT. If you want the good marks in these exams, then please like and share with your friends and subscribe and activate the bell icon for getting the all notifications from our VEDHA online classes. Okay, so differentiation, most important long answer questions, 7 marks questions. If root of 1 minus x square plus root of 1 minus y square is equals to a into x minus y, then prove that dy by dx is equals to root of 1 minus y square divided by root of 1 minus x square. Okay, so what is given here in this question? Given, okay, so root of 1 minus x square plus root of 1 minus y square is equals to a into x minus y. A into x minus y. Yes. Okay. So now I am taking x is equals to sine c and y is equals to sine d. X is equal to sine c, y is equal to sine d. Just I am substituting these values in this. Then under root of 1 minus sine square c plus root of 1 minus sine square d is equals to a into sine c minus sine d. Root of 1 minus sine square c. Okay, so this is cos square c. So root of cos square c plus root of cos square dt is cos square d is equals to a into sine c minus sine d. A into sine c minus sine d. Okay, so just written as it is. Here we applied the formula identity, that is sine square theta plus cos square theta is equals to 1. So 1 minus sine square theta means it is cos square theta. 1 minus sine square means cos square. Here square and root cancel, here square and root gets cancelled. Okay, so cos c plus cos d plus cos d is equals to a into sine c minus sine d. Direct formula we have. Where we have the formula for cos c plus cos d as well as sine c minus sine d. Okay, so direct formula I am applying here. Cos c plus cos d. Cos formula is cos sine sine. Cos formula is cos sine sine. We have plus means first part, cos means 2 cos c plus d by 2 and cos c minus d by 2. Cos c plus d by 2, 2 cos c plus d by 2, cos c minus d by 2. Okay, is equals to a into sine c minus sine d. Sine c minus sine d. Okay, that is a sine formula. Sine formula is sine cos sine. Sine formula is sine cos and cos sine. Okay, we have minus sign here. We have minus sign when we have the negative sign. When we have the negative sign, we get the second part, cos sign. We get the cos sign 2 cos c plus d by 2 into sine c minus d by 2. Sine c minus d by 2. Okay, so can we cancel anything? Okay, so here just check it, both sides we have two both sides, both are multiplying. Okay, if you take other side it will divide, so with that we can cancel cos of c plus d by 2, cos of c minus d by 2 also we can cancel, right?
Yes, sir.
Okay, so now
sir, c minus d. No, sir.
Yes, cos c plus d by 2, cos c plus d by 2 is same. Okay, and after that cos c minus d by 2 and sin c minus d by 2, that is different. That is different. Okay.
Okay.
Okay, so now here cos of c minus d by 2 whole divided by take this sign to left side. Here it is multiplying. If you take it to this side, divides. Sine of c minus d by 2. Cos by sine is equals to a. We have cos by sine is cot. Cos by sine is cot. Okay, so we get cot of c plus d by 2. We get cot of c plus d by 2 cot of c minus d, sorry, cot of c minus d by 2 is equals to a, is equal to a. Okay, so cos by sine is cot of c minus d by 2, okay, is equal to a. Take this cot to that side, okay, then we get it as c minus d by 2 is equals to cot inverse of a, cot inverse of a. Take this 2 to that side, here it is 2 dividing. If you take it to that side, multiplies. So 2 into cot inverse of a. Okay, now what is c, what is d? Okay, from equation 1, or okay, so consider it as equation 1. Okay, so x is equal to sine c and y is equals to sine d. Okay, so from here what we can write as c is equal to sine inverse x, d is equal to sine inverse y. Okay, so c means sine inverse x, d means sine inverse of y is equals to 2 into cot inverse of a. Okay, so how we are getting this? Okay, so since we are getting here sine x is equal to sine c, x is equal to sine c, that implies c is equal to sine inverse x, c is equal to sine inverse x, and y is equals to sine d. So that means okay, so here c is equals to, if you want clearly you can write it as sine inverse x, and d is equals to sine inverse of y. Okay, so now till here just a simplification part, till here just a simplification part. Now from here onwards we apply the differentiation concept here. So differentiating with respect to x on both sides, on both the sides. So now d by dx of sine inverse x minus d by dx of sine inverse of y is equals to d by dx of 2 into cot inverse of a, 2 into cot inverse of a, d by dx of sine inverse x, d by dx of sine inverse x. We have the formula 1 by root of 1 minus x square, 1 by root of 1 minus x square, d by dx of sine inverse y, that is 1 by root of 1 minus y square, and in place of x we have y, in place of x we have y, so d by dx of y it is. And okay, so if you take the right side part, 2 is a constant, cot inverse of a, that is also a constant. So complete all the terms are constant, d by dx of constant is 0, d by dx of constant is 0. Okay, what formula we used here? Okay, so d by dx of sine inverse x formula is very important here, 1 by root of 1 minus x square. And if you want, you can write the constant, d by dx of constant. What is constant derivative, ma?
0.
0. Okay, so now take any one term to that side. Okay, if you take one term to that side, then we get it as okay, minus 1 divided by root of 1 minus y square into dy by dx is equals to minus 1 divided by root of 1 minus x square. Okay, so now here minus gets cancelled, minus gets cancelled. So now this is in the denominator. If you take it to that side, dy by dx is equals to, here it is dividing, ma. So root of 1 minus y square dividing, if you take it to that side, multiplies root of 1 minus y square divided by root of 1 minus x square. So therefore, what is the dy by dx derivative here? Dy by dx is equals to, what we have to prove? Ma? root of 1 minus y square divided by root of 1
Root
minus
of
x square.
1 minus x square.
Is it the required answer?
Yes, sir.
Okay, or if you want, we can write the common root of 1 minus y square divided by, okay, so 1 minus x square, hence proved. Understood?
Yes, sir.
Any doubt ma in this till here?
No, sir.
Okay, just write it. If x to the power log y is equals to log x, then find dy by dx. Okay, so what is given here ma? What is given here? X to the power log y is equals to log x. X to the power log y is equals to log x. Okay, in this question, if you observe carefully, base is a variable and power also variable. When we have the function in the form of f of x to the power g of x, okay, or x to the power x, or variable to the power variable, then we apply logarithmic differentiation. That means we apply log on both sides. Now I am applying, okay, applying log on both sides, applying log on both the sides. Okay, if we apply log on both sides, then log of x to the power log y is equals to log of log x, log of
Log
log x.
x.
Okay, now we have the formula log x to the power n, log of x to the power n is equals to n into log x is the formula, n into log x is the formula here. Okay, so that means the power becomes a coefficient here, power becomes coefficient here. Okay, so here the log y is the power here. What is the power here? Log y
Log
is
y.
the power. Okay, this power becomes a coefficient. Okay, so what is the purpose of logarithm differentiation? Just okay, for writing the power as a coefficient. Okay, so that we can apply UV formula. Okay, so log y is coefficient. Now into log x is equals to log of log, log of log. After this, then we apply the differentiation, okay, on both sides, differentiating with respect to x on both sides. Differentiating with respect to x on both the sides, then d by dx of log y into log x, log y into log x is
Log
equals
x.
to d by dx of log of log x,
Log
of
x.
log. Okay, so now UV formula, left side we apply UV formula, so u into log y we write outside and differentiate the log, d by dx of log x.
Log
Okay,
x.
next what is next step?
Log x.
Log
D by
x.
dx of log y.
Very good. Okay, so log x is outside and d by dx of log y is equals to log of log x. Outside function is log, so inside we have logarithm, so 1 by x, 1 by x. What is x here? In place of x we have
Log
log x.
x.
In place of x, if you have any other function, then we differentiate that function. Don't forget here, internal derivative, chain rule. Is it correct?
Yes, sir.
Okay, so d by dx of log x we apply. Okay, so now then this becomes log y into d by dx of log x. What is d by dx of log x? 1 by x, and log x is as it is, and d by dx of log y derivative 1 by y, but in place of x we have y. We are differentiating with respect to x, but we have function is y, so that's why internal derivative in place of x we have y, so differentiate that y again, d by dx of y, d by dx of y. Okay, and is equal to 1 divided by log x as it is, and d by dx of log x, d by dx of log x is 1 by x, d by dx of log x is 1 by x. Okay, so write it as is. Now log y whole divided by x plus log x whole divided by y into dy by dx into dy by dx is equals to 1 divided by this x I am writing in the left side, x log x. Take this okay, left side term to right side. Okay, what I want here, I want the dy by dx. Okay, means okay, I keep this term in the left side. First send this term that side. After that send the remaining okay coefficient also that side. Okay, so now here log x divided by y into dy by dx. Derivative term we are okay, so keep it in the left side. Okay, and the remaining term I am sending to right side. 1 divided by x log x, and here log y by x is positive here. If you take it to that side, it becomes negative. Okay, so what we get minus log y by x, minus log y by x.
Log y
What
by
is LCM? What is LCM?
x log x.
X log x. X log x, x log x, we have same, so we write numerator as it is. We write the numerator as it is, and minus we have x, we have only x log x is not there. Multiply by log here. Okay, so log x into log y. We get
False.
log x into log y.
Log.
Log y. And what we have in the left side?
Log x by y
into dy
dy
by
by
dx.
dx.
Dx. But what we
Dx.
want the dy by dx value. Take this term, complete that side. Here it is multiplying. If you take it to that side, divides or reciprocal. Okay, just write it in the reciprocal. Dy by dx is equals to 1 minus log x into log y whole divided by x log x log x, and log x by x, if you take it to okay, so that side, then y divided by log y divided by log x.
Log
Okay,
x.
so finally we get the answer as dy by dx is equals to okay, so dy by dx is equals to y by x. Okay, if you want, you can write the y and x in the outside. Log x into log x whole square in the denominator. Okay, the denominator we can write log x into log x whole square. What about the numerator? 1 minus log x into log y, that is
Log y.
right. Okay, 1 minus log x
into log y.
log y. Okay, we write it as it is in the numerator. This is the required solution.